Hello everyone, I am Isha Kumari from the Department of Computer Science and Artificial Intelligence, and here is a presentation on a database management system. The topic for today is accessing database from application. Introduction. Importance of accessing a database from an application. Directly accessing a database from an application allows for a seamless integration and real-time data updates. It provides the ability to perform complex queries and retrieve specific data efficiently. Accessing a database from an application enables data-driven decision making and enhances overall application functionality. Benefits of accessing a database from an application: improved performance and efficiency in data retrieval and storage, enhanced security and control over data access and manipulation, seamless integration with other applications and systems, enabling data sharing and collaboration. So, database architecture. Database architecture refers to the structure and organization of a database system. It consists of various components that work together to store, manage, and retrieve data efficiently. Understanding the different components of a database architecture is essential for designing and implementing a robust and scalable database system. So, components of database architecture: user interface UI, forms, reports for user interaction, application logic, business rules, data validation, data management system, query processor, transaction manager, security, data storage, tables, files, indexes, data dictionary. Data access layers, database engine, middleware for connectivity. So, connecting to the database. Methods for establishing a connection: JDBC, which is Java Database Connectivity, a standard Java API for connecting to relational databases. Then ODBC, Open Database Connectivity, a standard API for connecting to databases using SQL. And ORM, Object Relational Mapping, a technique for mapping database tables to objects in an application. Protocols for establishing a connection. So, TCP IP, a widely used network protocol suite for connecting to databases over the internet. HTTP and HTTPS, Hypertext Transfer Protocol for connecting to databases via web services. Executing database queries. Types of database queries are select, insert, update, delete, and the function of these are: for select, helps us to retrieve data from the databases; insert, adds new data to the databases; update, modifies existing data in the databases; delete, removes data from the databases. Then executing queries from an application. To execute database queries from an application, you need to first establish a connection to the database, then create a query statement, then execute the query, and then process the result. Then retrieving and modifying data. For retrieving data from a database, application can retrieve data from a database using SQL queries. SQL select statements are used to specify the data to retrieve. The retrieved data can be used by application for various purposes. Modifying data in a database. Applications can modify data in a database using SQL statements like insert, update, and delete. The insert statement is used to add data to the database. The update statement is used to modify existing data in the database, and the delete statement is used to remove data from the database. Then handling database errors. Common database errors. When interacting with a database from an application, there are several common errors that can occur. It is important to be aware of these errors and how to handle them in order to ensure the stability and reliability of the application. Connection errors. Connection errors occur when there is a problem establishing a connection to the database. This can happen due to network issues, incorrect credentials, or database server problems. To handle connection errors, the application should provide appropriate error messages to the user and attempt to reconnect to the database. Query errors. Query errors occur when there is an issue with the SQL query being executed. This can happen due to syntax error, invalid table or column name, or incorrect data type. To handle query errors, the application should validate user input, use parameterized queries to prevent SQL injection, and provide meaningful error messages to the user. Then data integrity errors. Data integrity errors occurs when there is a violation of constraints or rules defined for the database. This can happen when trying to insert or update data that does not meet the defined criteria, such as unique key constraints or foreign key constraints. To handle data integrity errors, the application should validate user input, enforce constraints at the database level, and provide appropriate error messages to the user. Transaction errors. Transaction errors occurs when there is a problem with the execution of a transaction. This can happen when there is a deadlock, a timeout, or a failure to commit or roll back a transaction. To handle transaction errors, the application should use appropriate transaction management techniques, such as setting timeouts, handling deadlocks, and reassuring proper commit or rollbacks operations. So, what are the best practices? When accessing a database from an application, it is important to follow best practices to ensure efficient and secure interaction. Here are some recommended practices for accessing and interacting with a database from an application. Use a database abstraction layer or ORM, which is object relational mapping framework, to simplify database interaction and reduce the risk of SQL injection attacks. Then implement proper authentication and authorization mechanism to ensure that only authorized users can access and modify the database. Use parameterized queries or prepared statements to prevent SQL injection attacks and improve performance by reusing query execution plans. Implement proper error handling and logging to identify and troubleshoot database related issues. Optimize database queries by indexing frequently accessed columns, avoiding unnecessary join operations, and using appropriate data types. Regularly back up the database to prevent data loss and have a disaster recovery plan in place. Then finally we come to the conclusion. In conclusion, the components of a database architecture work together to enable efficient data management, from user interface and application logic to the database management system, data storage, access layer, and underlying data model. Each component plays a crucial role in ensuring data integrity, security, and accessibility in a well organized and optimized manner. The synergy of the components forms the foundation for effective database across various applications and industries. Thank you.